Hi there, this is another in our series of videos about the argoFloats package in the R language. The title is here, but first we'll start with introductions. I'm not Jaimie, but I'm Dan Kelley at Dalhousie University.
And I am Jaimie at Dalhousie University.
Good, thanks. So we're doing this by remote sharing because of the COVID crisis. And you're seeing my screen at the moment. And this is from the website for this package, and we've talked about it before, so I won't tell you what it is. So it's this one we're doing here. We're going to do a TS diagram color-coded by oxygen. And this is actually a little bit similar to this one, video number 2, but it's just going to show you more details, and we're getting into the kind of the reason why we like the R ecosystem for this sort of work. Some of what we'll be showing you is just basic R, and it's not really even related to the package. So I guess what I'm going to do now is I'm going to just scroll a little bit, and I'll show you that. And again, we're just seeing the website for the package here, and we have a directory called videos, and in that there's one called 05, and I'm just showing you now the code. So this is the code that we'll be doing, and code is online. So when we switch over to Jaimie in a second, she'll show you this code in our studio window, and she's going to walk through the first part, which is this part here, and then I'll walk through the second part, which is this part here. So over to you, Jaimie. Now I have to stop my sharing. Now, Jaimie, I think you can share your R3, whatever you want to share.
Great. So yes, I will start with my RStudio. Okay, so as Dan mentioned, we are going to do a TS diagram and color-coded by oxygen. At the end of this video as well, Dan is also going to kind of show the ties with OCE package. Just very quickly talk about that. But for that reason, I am going to load both packages. And then as we've talked about before, the next step is to just get the index from the server. The one thing that I will mention is compared to our last videos, this argument used to be called just file, and it is now file name, but aside from that, everything else is identical. So we're calling it AI, indicating Argo index. Our next step, again, we've showed this in a video before, is to just subset by circle. So all we're doing is we're subsetting this AI index. We choose our Latin long, which in this case is for the Bahamas. And then all we're saying is we want a radius of 300 kilometers. So I will just make that one happen. So as you can see, it's got 43 profiles. Now, this step is different, and we haven't showed this before. So all we are doing here is we're subsetting by parameter. So just to show you guys here, these are the different parameters that you can subset by. Let's see. Okay, that's actually the next thing. So right here, so if you use the user Argo manual, it just shows you the different parameters that you can subset by, and we can put this reference in the description of this video. So I just thought that I would show that pretty quickly.
Jaimie, can you scroll so we can see the page number of that one?
Yeah, sure. Let's see, where did it go? So this one in particular, okay, so page 80.
Table 3.3.
Exactly.
Yeah, thanks.
Good idea. So now I'm going to stop share and go back to my RStudio. This is where the magic will happen. Okay, so now, as you can see, so same idea, all we're doing is we're taking that circle subset and we are pulling out all the indices that have doxy or oxygen. So now what we're going to do is within this subset, we're going to get the profiles, and we've explained this before. Essentially, all that is doing is it's creating a list of the files that we want to download. And now we want to read these profiles. So just a very quick command, and I take a few seconds. Perfect. So now this step here, we haven't shown before, but essentially all this is doing is it's taking the oxygen within our Argos, and it's taking it out of a list and putting it into a vector. So that's all that's happening here. So I will make that command happen. So now this is showing kind of the close ties with the OCE package. So if you're not familiar with the color map command, you can always do question mark color map. And as you can see, what it does is it creates a map values to color. So essentially what we're doing here, as we mentioned, is we're creating a TS diagram, but we do want to color code it to oxygen values. So that's all we're doing here is we're saying, okay, we want to do a color map and we want it to be for the oxygen values. So all of this draw palette does is, well, you'll see, creates the palette. Oh, 1 second now. Here we go. Not sure why that happened, but there we go. So you can just see it's doing the gradient here. Now it isn't.
Jaimie?
Yeah, go ahead, Dan.
Yeah, it's just that happened because you hadn't run the line that said color, that said CM as a color map. You showed it, but you didn't run it, that's all.
Okay, thank you. What I will say here is for this particular palette, we are just using the default settings. But again, bringing you guys back to my Safari here. We just did want to point out this paper, which we can also reference in the description, and it's just the true colors of oceanography. And what they discuss in this paper is basically how to select an effective color map. So this can be really important for accurately showing different data that you're trying to analyze. But in this case, we are just going to do the default settings here. Back to our studio. And now all this last line 19, all that does is it plots our Argos. We're telling it that we want the TS diagram and that we want to color code it for the oxygen. So I'll make that happen. So there you have it. So Dan, I'll pass it over to you now.
Okay, great. Can you maybe stop sharing your screen?
Yes, I can.
And I'll share my screen for our studio. I have a warning, I'm a bit slower on this than Jaimie. Let's see, so I'm old school, so okay. So I don't have anything loaded. So my first step is I'm gonna have to run the code that Jaimie just ran. And I'm doing that right now. My numbers might be a little different. They seem the same as hers. It's just that if there happened to have been another float go through there between the day when she last downloaded the index and the day when I did, you know, it would be different, but it's not. Right, so I've loaded up and I've read the data. The get profiles actually, if you didn't have the data files downloaded, that would take a little while, and it would tell you for each of the 40, whatever it is, 41 profiles, it would tell you, well, I'm reading a .cdf file now, and it would give you a progress report on that. Right, so now that video, the image that you just saw from Jaimie, I find these a little confusing. And the problem with a color-coded image like that is that, for one, it's a painting model. Art takes a painting model, so it's like you paint some color, say red, on the white background, and then you paint on top of it blue. Well, then it becomes blue. So if you're plotting a bunch of profiles like that, the color that you end up seeing will be whatever was the sort of most recent point that you plotted. And sometimes I find that it can be a very evocative a diagram, but sometimes I find it more useful to look at it in a different way. Maybe first I'll show you exactly what Jaimie had. So that'd be different because of how our setups are, but actually it is different because I use the TS10 or Gibbs seawater method of describing seawater, and she's using the UNESCO method. So the labels on these diagrams are different. Now, what can you see here? We can see that there's low oxygen in this region of the water column. But I don't know the names of these colors, but this sort of very light blue, whatever it is, I don't know, it could be light blue here, and it could just be that the most recent 3 profiles that we plotted were dark blue. So I have a bit of a problem with that. It's evocative and can be more or less beautiful depending on the color scale you pick and so forth. It's also possible to just be very straightforward with this. And frankly, although this can be nice in a paper, I usually like to start in a straightforward way. That's what I'm going to show you here. So in this line, what I'm doing is I'm going to describe it by using the highlighter thing. So I'm saying Argo's square bracket pressure. What that's going to do is return a list of pressures, one pressure for each profile file. Some profile files have more than one profile in them. I don't know. I guess the profiles in them should be called cycles, perhaps. I don't know. Anyway, it'll be a list, and I don't really want a list. Honestly, this code would work whether you have a list or not, but I'm going to unlist it. That'll make a vector, just like Jaimie said. So this first one is going to get pressure, the second one oxygen. So let's just do that. I just ran those two lines, and then I ran the, oh, let me just clear the plot window because I want to get new margins. All right, so that's oxygen as a function of pressure. And if you know R at all, you can see what I'm doing in here. This is getting the range of pressure. Some of them are NA values because that's how the data sets work. If the float only went down to 800 meters, it puts NA values down below. So this finds the range and this reverses the range. That's the Y limit. So that's because in oceanography, you put on what's called a profile plot, you put the deep water at the bottom. From this, you can clearly see that there's a low oxygen, an oxygen minimum at whatever that is, maybe 800 meters or something. There's some other things that I find a little perplexing. We're in a 300 kilometer radius, I think, is what you used, Jaimie. Is that right? 300 kilometers? Yeah. So I wouldn't really expect to see very different water masses in the deep, but there seems to be one trend here and one trend here. And if I were looking at this more seriously and not in a fast video, I would probably look at that and color code by longitude or latitude to see if it's a spatial thing. I'd also look at time, and my guess is that maybe there was a time when, like, I just don't know what to say, that something happened there. Maybe some sort of water mass came in one summer or something. Okay, so now this is sort of a profile, but in oceanography, profiles are meant to have the label here at the top. It should say oxygen at the top, and the axis should be at the top too. And I can show you how to do that. I'll do this a little bit quickly. I'm making a CTD object, and the arguments for a CTD object would be something like this. Maybe I will run them, and you'll see what happens. So those lines that I've just, it's going to take a second. There we go. So what I've done here is I've created a CTD object with salinity, temperature, and pressure. I've added to that object a new thing called oxygen, and its value will be this O2, which we have already. I'm giving the unit here, and honestly, this is a bit of magic within OCE. There's just a particular way that you specify units. But by virtue of my having done that, then you can see that we have micromoles per kilogram there. That's what that is. And so this is a little bit fancier of a diagram. And maybe I'll end with just this. I'm going to make a 4-panel plot. I'm setting the character expansion factor to 0.5, which is small. Setting the character to 20, which is a filled circle. Setting the color to RGB 000, that means black. Alpha is the transparency, so 0.1. That means that the color will be sort of gray, and if I put another dot on top, it will be darker. That can be useful. I'm setting the Y limit just down to 1,300 meters. In other words, I'm skipping out. So I don't really know what's going on down here, and it looks like it's only, this is one float, and this is maybe 3. I can't tell, to be honest, how many there are in there. I'm just skipping them out just for now. That's what I'm doing in the Y lim. This first one here is going to plot a profile. It's going to be oxygen, and all this fancy stuff, which is the same for each of them, is just saying, well, that's the color I want and the character I want. So I'm just making all 4 of those lines happen. And you'll see oxygen now, and just like before, but we also see temperature, salinity, and sigma 1. This is the density anomaly reference to 1 kilometer depth. From this, you can tell what's called n squared, which is useful for some things. Mode water, which I'm quite interested in. I better not talk about because I'm too interested in it. So I think you can maybe see some advantages of this way of working compared to just the TS way. Honestly, I could have put a TS diagram here and reproduced it. It might have been interesting, but this sort of, the using not black symbols can be quite helpful because now you can see that there sort of is a core It's much darker here. So these traces here are just a few of the 41 or whatever it is profiles, but the main trend is clearly going along this line. Much more variability up near the surface, which I think makes sense because that's where it's interacting with the atmosphere, which after all is where the oxygen comes from. As to where the oxygen is going, if you're a physicist, you're thinking, gosh, there must be some current or something. But this gets into the wonderful multidisciplinarity of oceanography. I'll tell you, it ain't just a current. There's something else going on. Well, anyway, that's what we wanted to say. So we'll be putting this video up on YouTube in just a little while. So it's been about basically exploring oxygen in some region. This region we're looking at is in the Bahamas. And we hope you found it interesting. And I've been Dan Kelley.
And I'm Jaimie Harbin.
Thanks for watching.